Hi guys, this is Mrs. Donahue. I am coming you from my house for our digital snow day. So I will be recording myself writing our notes. Now I will post blank notes like these online. Otherwise I would suggest writing them down somewhere in your notebook or on just loose leaf so that you have them when we need them. And also the fact that I will be asking you about 3 questions on Schoology so that I know that you actually watched the video and took the notes. So just that to hold you accountable that way. If you guys could, please make sure you guys are following along with me. Feel free to pause the video as needed and send a message to me if you have any questions. So feel free to email me if needed. So understanding that I thought a digital snow day would work better for our section 7.4. So I'm skipping one section. So if you're looking in your notebook, I'm going a section ahead. So just that you're aware of that. But this one's a little bit easier to explain. Now, I understand that you might still have some questions, so feel free to bring questions to class. I'm not expecting you guys to become experts on special right triangles without me, but hopefully it's a good enough lesson that you guys can learn and be okay with it on your own. So feel free to use the book as well as needed. So understanding that we have in our warm-up here, we have sides marked the same. So this has to be a 5 as well. We have a little right angle, so I know this is an isosceles right triangle. Now, if this is 90, I should know these other 2 angles because isosceles triangles have congruent base angles. So these angles are the same, so they're both y. And this one's 90, so I should be able to figure out that 90 plus y should equal 180. Now, some of you guys already are saying I know what it is because it's a pretty straightforward problem, but if you're struggling, let's talk about it here. I'm gonna move the 90 over. So 2y equals 90. And again, pause is needed. So y ends up being 45 degrees. So each of these little angles is a 45-degree angle. So this is actually called a 45, 45, 90, which we'll talk about a little bit later here. Now, in order to find that other side length, since I knew these 2 are congruent and it's a right triangle, I can use Pythagorean theorem. So this is a special right triangle we're going to learn about today. So this is going to be 5 squared plus 5 squared will equal our x squared, which is our hypotenuse. So 25 and 25 will equal x squared. So 50 will equal x squared. Now, so that means I take the square root of each side. So x ends up being the square root of 50. Now, we would simplify that, and that would be about 7 point something. But in these types of triangles, there's a special pattern that shows up. So I'm going to simplify this radical. Now, square root of 50, remember we can break it up. We can break it up as 25 times 2. Now, square root of 25 is 5. Square root of 2, I don't know. So we're going to call this 5 square roots of 2. So that's what x is going to be here. So this is going to be a special right triangle we're going to talk about, that these 2 sides are 5, and then this one's just 5 square roots of 2. So we're going to learn that here in a little bit. So this is kind of warming us up for what we're doing today. So it says we'll use special right triangles to find missing sides and angles of triangles. So this is a 45, 45, 90 triangle. And again, we figured out that that had to be a 45-degree angle if this is 90 and this is isosceles. So this is our special right triangle. That's a 45, 45, 90. Now the sides, or the legs, it depends on the book, but I'm just going to call them X. Some books call them like L or just different variables. It doesn't matter. So those are the sides that are around the right angle. So they're on each side.